So I have a pretty good example in front of us today, which is a very complex medical device that the customer came to us because they had challenges getting the level of quality that they were looking for. So what we did is we first worked with the customer to understand what was most critical to them. In this example, they were very concerned about the fitment between the top unit and this moving door. They were also very concerned about the way that the edges lined up and any gapping or to minimize gapping. And so what we did is we first evaluated to what extent these features could be managed through the molding process. And so we are controlling this seam between these two molds. We are also molding in these features within this part. But then there are many features on this assembly that couldn't be managed solely through the mold, and that required secondary machining. And so what we do is we add features on the back of the form part. In this case, these are PVC blocks, and then we use secondary machining to make sure that the faces of the blocks are in the right orientation to the form surface, and then all of the hole centers line up in order to manage the fit and lock the parts in place. And so in this example, many features on this unit are within 5 or 10 thousandths of the dimensional callouts on the engineering drawings. We did that through a really intricate CNC setup process. We evaluated the parts using 3D scanning as we set them up, and then throughout the production runs, we monitor very closely specific critical to quality dimensions, and that really manages not only the first fit of the first unit, but all of the units thereafter. And this example has been a very good one that we have successfully made these parts through a few production runs with very little variation among all of these features that are critical to that customer. And it's been really a resounding success and something that we're quite excited about.